thanks for coming. As he said, I'm Trevor, and this is Roan. And I'll tell you a little bit about Roan. Roan is also an engineer at the Wikimedia Foundation. He works a little bit more in back end, and is a pretty critical part of our platform engineering team.
What are you talking about, dude?
He's we borrow him on the features team too. So, yeah, I'm Trevor.
And this is Trevor, and as he has been introduced by the organization, he's more of a front-end guy, and he does JavaScript development and he's a user interface expert. So the reason that we did this project together, and I should probably actually tell you that the project that we did and that we're presenting about today is Resource Loader, which is a framework for MediaWiki for delivering JavaScript and CSS and image resources to the browser. And the reason that it worked well for us to do this project together is that I'm kind of a back-end person, but I have some front-end experience because at some point I was shoehorned into a front-end development job. And Trevor is really a front-end guy and a designer, but he's also got back-end experience. And of course, our experiences kind of drop off towards the area where we're least comfortable, but together we actually span a very wide range of skills. And it meant that together we could design a resource loading system that was both efficient on the back end and actually usable for front-end developers. So the software that we work on is called MediaWiki, which is one of the most used wiki applications out there. It's written in PHP, and it powers the websites of the Wikimedia Foundation, the most famous of which is Wikipedia. And all of Wikipedia and the other Wikimedia projects run on open source software. So MediaWiki is open source software. It runs on PHP, which is open source. We use Linux, Apache, MySQL, Memcache, you name it. It's like, our environment is like 99% open source software. And we are the 5th most visited site in the world, but you probably already knew that. So
yeah, go ahead.
I'm sorry, dude. So this is a typical Wikipedia page. It's actually the main page of Wikipedia of a while ago. You can see this because Cadel Evans, your national pride, is on here winning the Tour de France in 2011, which happened a little while ago. And there are quite a number of resources on this page that make it slow to load. So we broke that down into a little graph here. The typical focus of a lot of website optimization is on HTML generation and delivery, but it's actually a very small part of the problem. Like, the HTML of this page is only, I'm going to guesstimate here, but like 20 kilobytes, and it's served in one request. This is not really your problem. What's really your problem is this. You've got almost 400 Ks of JavaScript, which before we got our hands on the website was served in 29 separate files, hence 29 separate requests. So this is where most of the gains are, and this is where we made most of our gains. Then you've got CSS, which is not an enormous problem. And images are small, but they do add up to a lot of requests because you've got a lot of like icons hanging around, and every icon is like less than a kilobyte in size, but it is its own separate request. And browsers only execute a limited number of requests in parallel, so if you got to do 22 separate requests, that actually takes a lot of time.
So, might kind of wonder, like, why are there so many resources going into something as simple as just like a read-only page, like our main page is? And you know, there's a bunch of different types of resources, as you said. You know, we have the scripts, JavaScripts. We have CSS files, and we also are transmitting over some internationalized messages for any of our dynamically generated user interfaces. We have our software translated into like 250 some odd languages, so we need to make sure that the correct language comes to the client. But the scary part is actually where they're all coming from, and that's what really causes the big problem. Some of these are coming from the core software. Some of these are coming from various extensions, and in different versions of Wikipedia, different Wikimedia projects, they all have different extensions enabled. So this is not really consistent. And also, we allow users to write their own CSS and JavaScript in their user space. And they can pretty much put whatever they want in there, and then that can trigger a lot of extra loading. So So this can all add up to a multi-dimensional problem of many, many scripts.
So I really wish that we had put the title of this slide in quotes, because this is about the optimizations that we were not doing before Trevor and I started revolutionizing the way we did it. Obviously, one of the things that's commonly done on the web is minifying things like JavaScript and CSS. We were not really doing that much. For one project, we realized like we kind of need minification. We don't have time to do it properly. So what we ended up with was the C implementation of JSMin that was run from a make file and generated a minified file that you would have to update every time you change the files, and that was a nightmare. Combination was something that we did sometimes. Same story. A make file that literally calls cat and generates a concatenate file and then minifies it. But we couldn't actually do this in the software because the software didn't really know anything about the JavaScript. It didn't know what to combine or what belonged together. It didn't know anything. And then finally, sprites are a somewhat popular technique. We used a few of them, but we didn't really use them much. Part of the reason is that we are driven by a largely volunteer development community, and they're not necessarily the kind of people that go and set out or are even able to make a sprite, because it's a very time-intensive process.
Has anybody here ever set up a CSS sprite? Did you enjoy it? One guy.
One guy.
We found this in our community, and it was an optimization technique that was really powerful in reducing requests, but hardly anybody would do it, and if they did it, they usually do it wrong.
Another problem with sprites also is that you cannot use them in absolutely every situation. There are situations where you cannot use sprites, or where your page will not, thank you, your page will not zoom correctly if you use sprites. The best that I can say in our defense is that we were using gzip. So we also had some problems related to caching. Now, Wikipedia like to think that we understand caching because we're a very large website and we survive because of caching. But in terms of client-side resources, we didn't really do it well. We had version resources such that you could, there would be a version number that you could increment to force the cache to update. But this version number was global, so the same version number was used for every image, every CSS file, every JavaScript file. So if you changed one thing, you had to change the global number and everything would get invalidated, which is not necessarily a very good idea. At the time, this didn't matter much because we hardly had any JavaScript, and then as we started adding stuff, we ran into this problem. The way we actually use the version number is we put it in the query string like this. The server actually totally discards the query string because a CSS file is not dynamic. But browsers and caches such as Squid actually recognize that !123 and !124 are distinct URLs and cannot be merged for the purposes of caching. They're different resources from their perspective. So that's what we used for cache evasion. If you increment the number, you evade all pre-existing caches for a resource. The whole system kind of sucked for purging resources, though, because in theory you could increment the version number, but it was baked into our HTML, and then our HTML was cached in Squid for anonymous users for 30 days. So you would potentially be serving old resources to certain users for a month before they got the new version, or you could get weird Frankenstein mixtures with all the new resources mixed together, or maybe one page had the new one, and another page had the old one. Crazy things could happen.
And all this kind of added up to it kind of sucking to be a MediaWiki developer, especially if you're working on front end, which both of us were for over a year trying to enhance the usability of Wikimedia. And we ran into most of these problems in that year. And at the end of the year, we were given the opportunity to kind of go back and fix the tools. And that's a huge part of what this project was. But what specifically sucked was just trying to get resources to the client at all. It was just kind of a ridiculous amount of setup. It wasn't really something that was considered to be a high priority in the early days of MediaWiki. And as we had more complex needs, we really outgrew it. As he was saying, how we had to manually concatenate and minify if we wanted to get any performance optimizations at all. Just maintaining that all the time, you know, like every other commit, you'd like forget to run the make file, and then you'd have all this nonsense in the SVN, and so that was just kind of a messy disaster. But this all really added up to our developers being distracted, and that means that they're not doing as much good work to make the user interface better, and instead they're just fiddling about with the software. So if we could solve this problem, we believe that we'd be able to accelerate the amount of work that we can get done to improve the usability of the site.
Another kind of unique issue that we had was that we are the largest open source website deployment in the world. So we have a significant amount of traffic. These are traffic numbers over the last couple of years. So we had about 250 million unique visitors per month a few years ago, and it was around 400 million in mid-2011. This chart unfortunately doesn't go any farther, but I think that the latest numbers for like late 2011 are somewhere between 400 and 450 million. I'm not exactly sure. But you know, that's a lot of traffic. So whatever you build, whatever clever system you come up with to make resource delivery nicer from a front-end perspective, also has to scale and has to work efficiently on the back end. So, and then another issue that's kind of unique to our setup is that there are a lot of possible sources for caching validation. Obviously, if you go in and change a JavaScript file in the software and then deploy that to your server cluster, then there is going to be a caching validation for if you're caching the file somewhere. That's, you know, that's fair, that's expected. You know, your operations department is causing that caching validation, so it's fine. However, like we said, there are users that can put JavaScript and CSS into wiki pages. And every single user has their own JavaScript page where they can put JavaScript that's applied just to them. So they can change that at any time, and that will require that the cache for that particular resource be invalidated. There are also site-wide JavaScript and CSS pages that apply to an entire wiki, which can be changed by administrators. But again, those are wiki users. It's beyond our control when that happens. And finally, because we send translated messages over to the client, translators can change those messages, and they have to show up really quickly. So that's another source of caching validations right there.
So when we started to approach this problem, we wrote up a big spec and came up with a lot of ridiculous ideas and did a lot of research about some other people's ideas. And it became pretty clear quickly that we really needed to focus on stuff that 2 guys could do in 6 months. That we weren't going to write Clojure compiler. Like we needed to do things that we could really get a lot of gains for essentially very little effort. And that drove us straight to the client. MediaWiki is actually pretty well optimized on the server side through a bunch of different caching mechanisms and a lot of back-end basically smartness. We're able to serve from the actual server really quite quickly. And by focusing on the client, we were able to just basically tap into all these completely untouched areas of optimization. And finally, since we just spent a year kind of drudging through this antiquated system, we really wanted to make sure that whatever we built was not something that was going to make it more complex. It needed to be much easier to use. It's always nice when you get to, as a developer, get to reinvent all your tools. But we also knew that this is probably a unique opportunity. This is not going to happen like every year. And whatever we came up with, we were going to have to live with for a long period of time. So the kind of foundation of what we came up with as an idea was that we wanted to reduce the number of requests, like most obvious problem. So we tried to figure out how much stuff can we cram into one package. So we came up with this idea, modules. We have scripts and styles and those internationalized messages that we're going to try and put those all into one package. So you only have to request it once by symbolic name, and you get everything, and it unpacks on the client. I don't know what just happened.
It's doing animation.
Oh, it's animating for you. So then we have all these modules. We want to be able to batch load them. So you can ask for a series of symbolic names in a single request, and packages it up and gives it to you. And this way we can kind of break things up logically, but we can really, really significantly reduce the number of requests.
So then we also did a number of clever things to the individual components that are going on here. One thing that we did with the JavaScript specifically is that we wrapped all the JavaScript in closures. So the JavaScript source for every module is delivered wrapped inside a closure. So this means you don't have to like load it as a string and then run it through eval or something. You can run it whenever you want. It's not necessarily run when it arrives at the browser, because the browser just creates an anonymous function and then puts it in a variable somewhere, and then you get to decide when it's actually run. And this allows us to do nice things with like dependency management, where modules might arrive out of order. Like some module might need to use jQuery UI dialog, but it might actually be loaded before jQuery UI dialog has even arrived. That's fine. You just put it in a corner somewhere, wait for jQuery UI dialog to arrive, execute jQuery UI dialog, and then execute the other thing. And that's all totally possible because we wrap everything in closures, so you can control when the execution occurs separately from when the loading occurs. We also do on-the-fly minification, which is to say we load all of our JavaScript is loaded through a PHP script, and that PHP script actually reads the JavaScript file from disk and minifies it on the fly. And thirdly, we allow for conditional loading. That is, a module can specify that these script files are only supposed to load if we're in debug mode, or if we're in a given skin, or in a given language.
We did a lot of clever stuff with style sheets as well. And I think one of the most powerful things that we did was data URI embedding. So this was basically a much better system than spriting, but normally people don't like doing this because it's a pain in the butt to copy paste the entire file, base64 encoding into your CSS file, and like constantly keep that synchronized. So what we did is we made it so if you add a little CSS comment that says @embed above a URL, that we just read it off disk, base64 encode it, and pop it in. There's some conditions if the file's too big or if you can't find it that we just pass over and ignore it. But being able to basically take advantage of the concept of sprites, where it's reducing the number of requests by only adding a comment, it allows us to use CSS the way it was meant to be used, and people actually use it, and they get it right. And it's really not that complex to do. I mean, once you get the base64 encoding done, you just kind of shove it into a normal background URL. So another thing that we had to do was remap all of the URLs that we didn't embed, because now we're loading everything from kind of like a load PHP script rather than its original path. Sorry, out of the frame. And so we had to go through and remap all the URLs so that they still all point to the right places. And finally, Wikipedia runs over 12, I think, about 12 right-to-left language. Yeah, right-to-left languages. And normally, we only, we would maybe have a couple of people in our community or on staff that knew how to write these flipping, kind of overriding style sheets that would make this work. But we figured out a way to automatically convert a normal left-to-right style sheet into a right-to-left style sheet. And in almost all the cases, there's really no extra work to be done, and we can just support those 14 languages just right out of the box. Of course, we also bundled them together, same as we did with the scripts, which reduced the number of requests, minified them, pretty simple there. Ended up being like 5 lines of regular expressions or something. We got pretty good efficiency out of that. And again, conditional loading. So when we have dynamic user interfaces, we can make them match the skins just by setting up different style sheets that load with different skins. And this all made it way, way easier to build these user interfaces.
So then for translated messages, we also did bundling, which in this case means that you have one server response that is a JavaScript function call that includes the closure with the JS code of your module. It also includes a string with all the CSS styles of your module, and it includes a JSON blob with all the messages of your module. So then when the module gets executed, the CSS is placed into a style tag in the DOM. The JSON blob is put into like a message store somewhere, and then the code, the closure, is executed. So that allows us to combine these three different types of resources into one JavaScript response, and that, of course, suppresses the number of requests significantly. And again, of course, with messages, you need to do conditional loading, because if I am visiting a page in German, then I want the German messages and not the English messages, nor the French messages, or anything like that. So a little bit closer to the implementation that we actually used. We have this implementation concept called the startup module, which is the first piece of JavaScript that actually runs on the page. The first thing it does is check, are we running on an ancient piece of crap? If, yes, indeed, we are running on an ancient piece of crap, then do nothing and just forget about it. Like, we do not support IE5 or Firefox 1 or any of that stuff that's way, way old. And then we just kind of like gracefully completely fail. Like, you will not get any JavaScript, and you will get the bare minimum of CSS, but no more. But you will basically not get any of the sweetness that we're talking about here. Secondly, it contains a registry of all the modules that exist and a dependency map saying which module depends on what. And that is used for resolving dependencies, that if you request something that needs jQuery UI, that jQury UI will actually be loaded as well when you request it, and that the module that you requested will not be executed before jQuery UI is actually present. And thirdly, we'll put in some configuration settings, which were previously output in kind of a hacky way because we were already exporting configuration variables to JavaScript. We put those in the startup module as well.
So now that we have the startup module, there's another piece of software, if everything's OK, that's the first thing that it loads, which is the client-side loader and also jQuery as part of the initial package. And client-side loader is responsible for resolving the dependencies. If there's anything that doesn't exist yet that needs to execute something, it just goes out and grabs that, and it can kind of bundle those all together to try and reduce the number of requests there. It can also handle batching, so that kind of queuing mechanism that makes it so when you ask for kind of 5 things in a really short period of time, it can kind of grab those all together and then expand them individually. And also the actual mechanism for expanding them, which is kind of what he was talking about with putting the messages in the right place, putting the styles in an actual DOM element so that they get used in the browser, and making sure that the messages are now available for the JavaScript to be to use once it's executed.
So as I said before, we did caching pretty badly previously. So let's look at how we actually did it now. We decided to still use query string parameters for versioning, except that instead of increment numbers, we now use timestamps, which correspond to the last modified timestamp of whatever you're requesting. The last modified timestamp of the module is computed on the server and is part of the module metadata that is served in the startup module. So the startup module contains the metadata that tells you when a module was last changed, and based on that we produce dynamic URLs for loading them, which include that timestamp. That means that the startup module itself, of course, has to be refreshed fairly regularly because you don't want it to take forever for a change to take effect. So the startup module itself, with the module manifest, with the dependency info, and the timestamp information, is cached for 5 minutes, both on the client and in the varnish caches. And then the resources themselves are cached for 30 days, except that we use cache evasion with a timestamp parameter. If something changes, we request it with a different URL that's functionally the same, and that will bypass the cache. So in implementing this system, we learned a lot of things that our original spec didn't really cover, and it was a fairly iterative process. But also some of the things that we suspected were greatly confirmed. This is not the order in which we intended it to be. But that's okay. That's okay. We can improvise. So one thing we find out is that the order in which you load things and where you put things in the DOM actually matters. So the traditional way of loading things before we started doing stuff was this, where you just have a script tag in the head, and it has a version number, which isn't numerical, just an incremental number, and it's baked into the HTML, which causes huge problems when you try to then cache that HTML in Squid or Varnish, because you're going to get stale versions that are never going to go away, or well, at least not for another month. And that's basically a nightmare that we tried to solve. So what we did was we said, there's going to be a registry, and then we're going to generate a script tag dynamically with a dynamic version parameter, and then we're going to use document write to, this is actually a disclaimer, this is actually one of the few non-evil uses of document write where you can actually do it. We're going to use document write to add that script tag to the head still. Of course, then you get the whole Steve Sauter spiel where he says script tags in the head are bad because they block not only the rendering but even the parsing of anything that's below them until the scripts have been downloaded and executed, which is true. Like if you do this and the startup module takes 5 seconds to download, nothing will happen for 5 seconds, and then the browser will start parsing the body tag. So this is undesirable, and what Steve Sauter tells you to do is move it down to the bottom of the body. Right, so we were good citizens and we did that. But then we figured out, well, there are some things you actually do want to do in the head before anything has happened yet. Like if you want to have a CSS class automatically applied when you're in Internet Explorer or something, we did do that kind of stuff, then you need to do that before the document is rendered, otherwise you get a flash file style content. So, we moved jQuery and the startup stuff back into the head, and then at the bottom we have a call to the loader that loads all the stuff that can load late. And then on top we also have a call to the loader that loads stuff that needs to load early. This actually worked pretty well, and this is actually what's live on Wikipedia right now. Pretty much in the week before we came to Australia, we experimented with yet another technique where we actually move the bottom stuff, so the stuff is loaded asynchronously using DOM methods rather than document write. We actually picked that up and moved it up to the head as well, while still using DOM methods to inject it. It's a technique we kind of stole from Head.js without all the scary undocumented code. And that's something that we're experimenting with. It's an experimental feature, and the benefit of doing that is that the scripts will still load asynchronously, so they will not block parsing or rendering of anything, and they will probably still run after the document is ready, but the request will be fired off earlier, because the way it's done now, the browser will not fire the request to get the module until it's already rendered the page. And of course, actually in the previous talk right before lunch that I went to, there was a very big stress on do stuff asynchronously, fire the request off as soon as you know that you need it. So that's what we're experimenting now. Fire off the requests from the head, but don't block on it, which hopefully will make stuff faster, but we're still experimenting with that. So another thing that we learned is that embedding is very, very effective. This is the data URI embedding that we were doing in the CSS files. The CSS payload was about 4K, and then there were tons of images. And to be fair, not every single one of these images was used in every single page, but there are a lot of pages that used almost all of these images, and it's basically an unacceptable number of individual requests. But the way that these were actually being used in the content precluded us from using a sprite because of the mechanics of CSS. By embedding them, we were able to get it down to only one request of the styles and the images, and impressively, to the credit of gzip mostly, it was like a super sprite, right? Like it really put all these images into one body of content that gzip could get its hands on, and it was able to do what it does really well, which is find common bits and compress them together. So all the PNG headers, all the white pixels, what have you, they all got merged together, and it's basically the exact same benefit you get from putting all your images into a sprite, but without the hassle. Another thing that we discovered is that for for minification, because we do it on the fly from PHP, we use jsmin.php, which is essentially a port of the C implementation of jsmin. It wasn't actually written by Douglas Crockford, but it was written by, I don't know, someone. It's pretty much a literal port of the original jsmin source, though. However, it is kind of slow. If you run jQuery through jsmin.php, it takes almost a second, which, from the command line, minifying something, it takes a second, whatever. No one cares. But if you're doing it on the fly, while someone is out there waiting for the web request to finish, a second is an eternity. So one of our very kind volunteer developers, called Paul Copperman, thought that he could write a better JavaScript minifier. And he was right. He wrote a custom thing that we call JavaScript minifier.php, and it minifies jQuery in 1/4 of a second. It is not as efficient as JSMin in terms of minifying the output, in that it doesn't do some of the more ridiculous things. And as a result, the output of JavaScript minifier.php is slightly larger than it needs to be by about 0.5%. But no one cares about going like 3 extra miles, about like spending 4 times as much time to get to squeeze that extra 0.5% of minification out of the JavaScript. That's just not worth the effort. It also had some, there were some edge cases where JSMin will produce invalid JavaScript where that JavaScript minifier actually didn't do, because it's a proper stack parser for JavaScript. And it's standalone code, it's open source, it's licensed under I think we licensed on the Apache license rather than the GPL that MediaWiki is under. And you can download it right there and use it in your code.
And that's also, it lives in a part of the MediaWiki repository that has a few other standalone libraries as well.
Another library that we ported was CSS Janus, which is a library that does left to right to left flipping. It's originally a Google project, and it was originally written in Python. And I ported it to PHP and fixed a few bugs. It seems that Google's not really maintaining it anymore, though, which is kind of too bad.
Yeah, because really, this piece of software, it's really kind of crude and regular expression based, but it is a gem. We've really found that it's far more consistent and able to basically make all of our user interfaces right to left with virtually no effort. There's some ways to get around things. If you intentionally need to work around a browser problem, you can put a comment above a rule or a property that says no flip. But essentially, the vast majority of all of our user interfaces just instantly, magically worked, and they kind of continue to do that, and we don't have to have a lot of specialized skills throughout our entire front-end development community just to be able to support these smaller languages. And because it's only 14 out of 250 something, they tend to get overlooked, and it was really nice to be able to make sure that this gets done automatically. Another thing that I think what happened is we got a little overzealous with the way that we were batch loading everything. And we got to the point where we said, well, let's just load everything in one request. And that doesn't really actually work that well. There's a lot of cases where from page to page, you get cache fragmentation problems. So we came up with a simple system where you can just assign a group to something, and it'll always load that in its own request. And a good example of this is like jQuery UI, which is pretty big and kind of randomly used and would otherwise kind of bloat a lot of individual payloads. And this way, once you've downloaded it once, you have it. And this is kind of something we can use to tune as we kind of see the usage patterns of various pieces of software that we write.
So, of course, what's more important is that it actually worked and accomplished the goals that we wanted to accomplish. So remember this graph that we showed earlier. After we were done, it looked like this. We got the number of JavaScript requests and their size down a lot because we're loading less stuff that we didn't need to load. There is still a number of, the number 7 requests for JavaScript is still more than it needs to be. That was mostly the fault of user-generated content that includes JavaScript that we didn't optimize properly. There's the follow-up project going on for that right now. And the 4 image requests actually do not include any of the icons. The icons are in the CSS. The 4 images is just like the image of Cattle Evans's face, which is like a 100 KB image, and you can't data URI embed that. You can't do a data URI for that because if you try to create a data URI that's larger than 32,000 characters, then IE will choke on you. So you still need to load those images individually.
Typical.
Yeah, IE. Also, it's efficient on the back end. So we have not as many servers as people probably think. We have about 400 servers, There's another 300 or so that are coming online in the secondary data center, but they're not up yet, and they certainly weren't up when we deployed this stuff. At the time, we used 4 application servers, 4 Apache servers for delivering resources, and 9 Varnish servers for caching the output of those Apache servers. We had 90,000 requests per second on our peak load. 40,000 of those were for resources, and 73, just 73, less than 100, for them were cache misses, so we had a cache hit rate of 98.2%, which is pretty sweet. If you look at the usage graph, CPU usage graphs of those application servers in Ganglia, they're basically, there's 4 of them, but they're basically sitting on their asses all the time, like 5% CPU usage. And then when someone changes a file, they spike up to 100 and go back to sleep again. It really works quite well.
So we called this system Resource Loader. And a lot of the things that we wrote, we tried to make as much of it into individual libraries, the data URI embedding, things like that. But it is a lot of the other code is kind of baked into MediaWiki, and we really hope that other people can take these techniques and start using them in other places around the web. It makes the web a lot faster place. But it's important to remember when you embark on these projects to focus on easy gains, and taking 4 times as long to generate something for 0.5% of compression. That's not worth it. There's a lot of really clever ideas out there of how to like pack JavaScript and unpack it and everything, but when you really look at the grand picture, it's so much more about just reducing requests, doing the kind of the straightforward minification stuff, and just trying to figure out the way your application really consumes the resources and in what time order, and just kind of grouping things logically. And really focusing on the client. So much of web performance is always considered to be this server problem. And in reality, most of the time, people are just waiting around for things to arrive that are like static. So that you can't really say that that's like a processing problem on the web server. PHP, as you saw, it counts for such a small amount of the time that people are waiting around for things. So especially once we cache them, then PHP is completely out of the picture. So we need to be focusing on how much stuff are we really sending to the client and how can we reduce that. And finally, anytime you're building this kind of stuff, we really need to make sure that developers actually like to use it, or else they just won't. And they'll go back to the old way or whatever's the most comfortable way. And since this is all about trying to make it a better user experience on the website, we really want this to be the path of least resistance for people. And just because it's all about the front end doesn't mean you should totally ignore your servers. We worked really aggressively to make sure that we had really efficient caching. And working on this huge amount of traffic, we knew we weren't going to get away with being lazy in that department. And Roan did a great job of making sure that everything ran really efficiently on that side. But there is a balance to be struck. And in the end, when you pay attention to this type of stuff, it really translates into people liking your web page better. And perception of performance is just as important as actual performance. So thank you very much for coming. We'll say one more thing real quick before questions. Go ahead.
So yeah, we are here also we kind of perennially have job openings at Wikimedia because we are still understaffed. So if you are interested in doing the kind of cool project that we've done and that we've talked about, or are interested in working for Wikimedia for any other reason, go take a look at jobs at wikimedia.org. We have a bunch of job openings, both in tech positions on both the front end and the back end and in operations, and also non-technical positions. So definitely check it out. The presentation is not online yet, but we promise it will be soon.
There actually is a version of it, but slightly different.
Slightly different. This version will be up soon, Wi-Fi permitting, at wikitech.wikimedia.org/presentations. The second link is for documentation on our wiki about Resource Loader, and we will take questions now.
I'm going to have to steal the microphone. So
yeah, sure.
Yeah, there we go.
If you have to answer, I'm going to have to.
Yeah.
With the versioning parameter you had for the cache busting. I was wondering, did you mainly do that because of problems with using things like HTTP headers for the cache timeouts instead?
Well, cache timeouts are fine, but mostly what we wanted was to have basically more or less on-demand invalidation.
On the squid layer.
Yeah, on the squid layer. So, but also on the client-side cache layer. So if you use a timeout, then you're going to have to strike this balance between, well, if I cache it for a long time, it's more efficient, but it's not actually going to updates are actually not going to go through quickly. And this, of course, gets you the best of both worlds. You get an insane expiry time, and you get 5-minute invalidation.
So you by default set pretty long cache expiry times in your headers?
Yes. So everything except for the manifest that says how old everything is, everything except for that is cached for 30 days. And only the manifest.
Forever.
It may as well be forever, but for practical reasons, we say 30 days, just so that if we screw up, it's not forever. And the timestamp manifest is cached for 5 minutes. But that's like a kilobyte of data.
Questions? Over here?
Hey, so before you were talking about using JavaScript to manually asynchronously load scripts so that it doesn't block parsing of the rest of the page. So in HTML5 there are a couple of attributes you can put on the script element, the async and defer. Are there particular reasons why that's not usable?
If they had been reliably supported in older browsers in 2009, we would have totally used those.
Yeah,
Okay.
I'll take a little bit.
And also, we need to dynamically generate our script URLs because of the timestamp versioning.
Yeah, I would also just say that we try and support a lot of old browsers. When I changed the skin of Wikipedia, for instance, and we released that in 2010, we were still supporting IE 5.5 for reading. And we wanted to make sure that we had something that would work for everything that we're planning on supporting. And for us, that's anything with 0.1% market share or greater. So I think in coming years, we'll be able to take advantage of that stuff, but we got to wait for a lot of things to cool off first.
Okay, cool. And just one quick follow-up. Are you planning on deploying Speedy on the server?
There are no current plans for Speedy, no. I haven't actually looked at the technology much. But we probably should take a look at it, but we haven't actually done it yet.
I would just add that we have a lot of ideas of ways that we can make this even more dramatically faster using things like edge side includes and a variety of other ideas too. And so it's a project that's continuing to evolve, and I think we're going to continue to get more and more performance gains.
Behind you?
I like the way that you've made everything very modular, because that's good. You can pick out the bits that you want. Coming into it though, without seeing the overall process and workflow, is there something that you're putting together at that second URL that sort of talks about, from a developer's perspective, how do I use all of these components to get the results that you guys have been able to manage getting by using lots of cool little bits?
It's kind of supposed to be designed that you can just do it the way you want to do it and it just works. We haven't actually really documented like this is how you should do it in order for the performance not to suck. But generally, we haven't really experienced a lot of problems with that. Like once you convert things to be modular, just like to a sane standard, it pretty much just works. And it hasn't really mattered much, except maybe on the fringes. So we haven't really bothered to document it much.
And if you're trying to implement this in something other than MediaWiki, feel free to hop on IRC or email us, and we'd be happy to walk anybody through a lot of the work that we did in a little bit more granular detail and point out some of the libraries and some of the tricks. But it's all open source code if you want to view it,
Amongst versioning in your URLs, manifests, and that 5-minute caching, do you see issues where something's been updated on the site, but only part of it gets updated when the client gets it and another part is cached?
That doesn't actually happen. I think that architecture doesn't really allow that much. It's essentially because we have combined requests that load multiple things at once, we take care that the timestamp that's used for that request has to be the highest timestamp of all timestamps involved. And we've never had a problem where things get out of sync like that, unless like someone screws up and indicates the dependencies incorrectly, or stuff like that happens. But because it's based on file system modification timestamps, and we don't do any crazy stuff on our deployment hosts that would screw this up, it never really goes wrong.
I would also add, like, we used to have this particular problem that somebody would change an image, maybe like how much white space is around an icon or something, and they'd make a CSS change that also reflected that, and those would get synced at wrong, at the different times. And so sometimes people would see the icon a little off for a while, and it eventually would sync up. And I don't know, we didn't really explicitly call it out, but when we talk about a module and its highest timestamp, that includes images that are referenced by the CSS URLs. So yeah, so we dig really, really deep to anything we could possibly figure out, and that also includes like if a message has been updated on a module, it'll make the whole thing invalidated. So I mean, even if it was done on Wiki. So yeah, we pretty much chase it down as far as we can go, and that's I think why we haven't really had those problems.
If it's a quick one, we actually have to kind of wrap this up towards, otherwise we're going to run out of room or run out of time getting to the next session.
So last question.
Last question.
The comment that in the CSS that does a data URI, how many edge cases does that script cater for? Like sizes and things like that?
Yeah, it pretty much, if it's under 2K, it's fine. There's one edge case that has to do with Internet Explorer 6, of course. In that case, we lucked out. It's 6.7.
6.7 don't support data URIs.
Yeah, so they don't support data URIs at all. There's a weird, funky other thing we could implement. Somebody's come up with otherwise. But anyways, basically all we do there is we fall through to a rule that at the end it says exclamation point IE, and then all browsers ignore it unless you're IE, and then it just loads it. And that's your punishment for using that browser, is that you don't get the optimization. Thank you very much.
On behalf of the organisers of